Lit Mathematics. Chapter 12 Statistics and Probability. Lesson 7 Theoretical and Experimental Probability. Learning Objectives. Find and compare experimental and theoretical probabilities. Predict the action of a larger group. Keywords: uniform probability mode, theoretical probability, experimental probability. In a uniform probability model, each outcome has an equal probability of occurring. For example, some carnival games involve spinning a wheel to win a prize. If each prize is equally likely, you can use a uniform probability model to calculate your chances for winning a particular prize. Theoretical probability is based on uniform probability. What should occur when conducting a probability experiment? Experimental probability is based on frequency. What actually occurs during such an experiment? If the number of trials is very small, there can be a wide variation on results. Example 1. The table shows the results of an experimental in which number cube was rolled. Find the experimental probability for rolling a 6 of this experiment. Then compare the experimental probability with the theoretical probability. Number of times 6 is rolled divided by number of possible outcomes. Number 6 is rolled 6 times. So 6 times divided by the total number of the possible outcomes. 4 plus 6 plus 2 plus 8 plus 3 plus 6 is 29. The experimental probability of rolling 6 in this case is 6 divided by 29, or about 21%. The theoretical probability of rolling a 6 is 1 over 6, or about 17%. So rolling a 6 in the experiment occurred more often than expected. Make prediction. You can use theoretical or experimental probability to predict future events. Example 2. The table shows the results of a survey that asked 200 teens what they would be doing if they were not online. Out of a similar group of 450 teens, predict how many would listen to music. In this table, we can see teen hobbies of watching TV 50, listening to music 52, physical activity and sports 54, read 18, write and written, and other 16. For the experimental probability that a student listening to music is 52. So 52 divided by the total number surveyed. Now 52 out of 200 simplified to 26%. Out of 450, there are 26% listening to music. The percent is 26%, and 450 is the whole. Let n represent the part. So, applying proportional relationship, n divided by 450, which is part over whole, equal the percent, which is 26 over 100. Applying cross multiplication to solve for n, we will get 100n equal 26 times 450. So n equal 117. Now, if we need to check our solution, we will estimate 25% of 450, which is approximately 110, so 117 is reasonable. Next question 1. The table shows the results of an experiment in which a number cube was rolled. Find the experimental probability of rolling a 4. Then compare it to the theoretical probability. Of rolling 4 here we have only 3 frequencies. So the experimental probability of rolling a 4 is 3 divided by the total frequencies, 3 divided by 15 or 1/5. So probability of rolling a 4 is 20%. The theoretical probability of rolling a 4, it's 1 over 6 because we have 6 faces and 4 occupied only one face. So the probability of rolling 4 in the theoretical probability is 16.67%. So the experimental probability is greater than the theoretical probability. A jar contains 40 red marbles, 18 blue marbles, 20 yellow marbles, and 12 green marbles. Ali chooses a marble at random. Notice the result and replace the marble. He repeats this until he has done it a total of 45 times. Predict the number of times he will choose a red marble and explain. Step 1 is to calculate the theoretical probability of choosing a red marble. So probability of choosing a red is 40 out of the total, which is 40 plus 18 plus 20 plus 12. So it's 40 divided by 90 or 4 over 9. So probability of selecting red marble is 44.44%. Step 2 is to use the theoretical probability to find the number of times of choosing a red marble. 45 times 44.44% is 19.998, which is approximately 20 times. Thus, Ali will choose a red marble 20 times out of 45 times. Justify conclusions. Based on the past session, the experimental probability that a basketball player will make a free throw is 0.76. The player needs to make 5 out of 7 free throws to win a free throw tournament. Do you think the player is likely to win the tournament? Justify your answer. Probability of free throw is 0.76 or 76%. The player needs to make 5 out of 7 free throws to win. So probability of winning is 5 out of 7, which is 71.4%. Since the probability of win is less than the probability of free throw, the player is unlikely to win. Activity. The table shows the results of a class survey about students' favorite X Games sport. A. What is the probability of skateboarding being someone's favorite sport? B. Suppose 800 students in the school are surveyed. At this rate, predict how many will choose inline skating as their favorite sport. C. Of the 800 surveyed, predict how many more students will prefer BMX than Moto X and explain. A. Probability of skateboarding. Skateboarding is 15 in the table and the total is 8 plus 6 plus 4 plus 15 plus 7. So we came up with 15 out of 40 or 3/8. B. For A, we know that 3 out of 8 play skateboarding. N divided by 800 equals 3 out of 8. Applying cross multiplication to solve for n, we will find eventually that n is 300. Thus, 300 students out of 800 play skateboarding. C. Observe that the number of students who prefer MBX is double the number of students who prefer MotoX. Therefore, out of 800 surveyed, the number of students who prefer MBX will be double the number of students who prefer MotoX. A survey found that 95 households out of 150 have a gaming system, and that 125 households out of 200 have a pet. What is the probability that a household has both? First, we will find the probability of having gaming system. So the probability of gaming system is 95 divided by 150. And the probability of having a pet is 125 divided by 200, or 5 divided by 8. The probability of both is the multiplication of the probabilities of both events. Multiply 95 divided by 150 times 5 divided by 8. And simplifying this expression to get the probability of both is 19 divided by 48. So the probability that a household have both gaming system and a pet is 19 out of 48, or 0.3958. What have we learned today? We have learned that a uniform probability model is when each outcome has an equal probability of occurring, and experimental probability is based on relative frequency. We also learned that theoretical probability is based on uniform probability. Scenario. Najat has a set of 5 cards numbered 1 through 5. She shuffles the cards and chooses one card at random. She repeats the process several times and records the results in the table below. Based on her results, what is the experimental probability of choosing a 1? The frequency of 1 is 6, so the probability is 6 divided by the total, which is 6 plus 4 plus 5 plus 3 plus 7. So the probability is 20%. In a survey, 60 students were asked to choose their favorite type of film, and 27 of the students choose action films. Out of a similar group of 480 students, which is the best prediction of the number of students who would choose action films as their favorite type of films? First of all, we will find the probability of 27 divided by 60, and that should be equal to n divided by 480. And then we will apply the cross multiplication to solve it for n. So there are 216 students out of 480 students who choose action films. Wafa has a bag containing red, blue, and green marbles. She chooses a marble at random. Notice the color and replaces it. She does this 12 times and finds that she chose a red marble r times. Which of the following is the experimental probability of choosing a red marble? Yes, you're correct. It's r out of 12. That was everything of this lesson. Remember that process makes progress, so you need to practice some question by yourself. Thank you for watching and see you next time.